Today I'm taking over a very controversial chapter of mine, at least. I do not like this chapter. And it's like the official parting season now. I do not like this chapter. I would not like it. Nothing would make me like this chapter. Okay. But still we have to do this. So I am using the mind map series from Rahul Dudi sir. Let's get started with it. Reversible types of chemical reaction. There are two types: reversible reactions and irreversible reaction. Proceeds in both direction, forward as well as backward. Also known as bidirectional chemical reaction. Concentration of the reactant will not be zero at any point of time till infinite time to its completed equilibrium is defined. Proceeds only in one direction, forward direction, unidirectional chemical reaction. Concentration of reactants will be zero at the time of completion. मतलब reactants takes finite time to complete. Equilibrium is not defined. Concept of equilibrium: the forward reaction, backward reaction, the rate of the forward, rate of the backward, such as like this. This is called a physical equilibrium. Solid to liquid change হচ্ছে আর এটা যখন হচ্ছে এটাকে বলে একটা chemical equilibrium. At equilibrium the properties like pressure, temperature, concentration do not show any change with time. Pressure, temperature, concentration. Equilibrium is attained when the rate of the two opposite processes become equal. Physical equilibrium. The rate physical equilibrium. At equilibrium, rate of the melting is equals to rate of the freezing. Rate of the freezing. Vaporization is equals to rate of condensation. In sublimation, rate of dissociation is equals to rate of crystallization. In gas of a liquid, we can say soda water. In Henry of gas in a liquid. Directly proportional to the P is equals to Kh into P, and this is known as the Henry's constant, and this is the partial pressure. That's the Henry's constant, and this is the partial pressure of the gas, and this is the Henry's constant, and this is the M. This is chemical equilibrium. Law of mass action. This is the rate law. The rate law, you can see these are the coefficients which we did. This is the rate constant. The forward reaction and backward reaction. As with time, rate of formation goes down and rate of forward reaction goes down and backward reaction increases. At equilibrium, both are same. The constant concentration of reactant and product, they are the same. Constant. It says constant, not equal. The concentration of reactant and product must be constant but not equal. Okay, the rate and time. This is a very common question. Rate and time at equilibrium. When the rate are same, the concentration must be constant. So this is the time where the equilibrium is. The concentration must be constant. Constant or same. It can be same, but main thing is that it should be constant. Law of chemical equilibrium and equilibrium constant. Kc is for concentration, Kp is for partial pressure. Kp for partial pressure, Kp is equals to Kc RT delta Ng. Concentration Kc, then Ng is number of gaseous moles of product minus number of natural moles of reactant. So PCl5, this is 1, this is 1, minus 1. 1 minus 1, 1 is the N delta N. Kc is equals to partial pressure of this, partial pressure of this, partial. What is Kp? Kp is equals to Kc into delta Ng. In this case, it is 1. Chemical equilibrium. Homogeneous equilibrium, same physical state. Homogeneous equilibrium same physical state এ সব কিছু আছে, যেমন গ্যাস 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 সবই গ্যাসে আছে। তো এই ক্ষেত্রে কি হবে? this is the same 0. So Kc is only present here. In this case, different physical state is there. Kc is equals to this, 2 minus 1 1, Kp is this. Kp is not available, it's just told here liquid 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 liquid. Kp is not formed here. Okay, I was wrong here. The Kp is not formed because all are in liquid here, but in this case it is formed, and the partial pressure of all you have to write like Ng partial pressure of H2 and partial pressure of N2. In this case also it's the same, but in the case where like this, a solid is there, forms a solid and a liquid, is equals to 1, Kc is equals to this, and Kp is equals to partial pressure of carbon dioxide. Characteristics of equilibrium constant: independent of the initial concentration of the reactants of the product, it does not depend. Temperature dependent, having one unique value of particular reaction. It is temperature dependent, having different equilibrium constant at different temperature. For the reverse of the reaction is just the inverse. Like if this is K, you go B to A and the reaction is K, so A to B gives the reaction of 1 by K. When a chemical reaction is multiplied by a factor, it a power is chole jaye tar, which chemical reaction is written in one and more than one steps, eta tale K1 is equals to K2 into K by K3. Ajali subtract you have to do, then you have to divide it. Okay, effect of temperature on equilibrium constant. We just now have read that it depends on temperature. So how does it depend? So there is a formula that is log, where is my pen? It's pretty, right, this pen. Log K2 by K1 is equals to delta H 2.303 R root over 1 by T1 minus 1 by T2. K1 is the equilibrium constant at temperature 1, K2 is temperature 2, given that temperature 2 is greater than temperature 1. And if there are three conditions, if this is 0, if delta H is 0, this means equilibrium is there. So the delta H is 0 means no temperature change, nothing changed, so it is just like K1 is equals to K2. If the delta H is positive, it means that it's an endothermic reaction. If delta H is positive, okay, if this is positive, taken that this would be positive and these are all positive, so this should be positive. For this to be positive, K2 by K1 must be greater than 0. So K2 must be greater than, must be greater than 1, because 1 is log 1 is 0, so it should be greater than 1 is equals to 2. Or we can say log K2 by K1 must be greater than 0, so K2 by K1 must be greater than 1, so K2 must be greater than K1. If it's negative, it's exothermic. If it's exothermic, then it is negative, so log K2 by K1 must be less than 0, that is K2 by K1 must be less than log inverse of 0, that is equals to 1 K2 by K1. So K1 must be greater than K2. This is the thing. So in this case, temperature increases, but as K2 is less, the equilibrium constant decreases, and in this case increases. So there are just two cases we have to learn. Application of equilibrium constant, predicting the extent of the reaction, okay, is equals to product by reactant, right? If the equilibrium constant, if it is increasing, it is greater than, it's increasing, if it is greater than 10 to the power 3, the product is greater than the reactant. If it is decreasing and it is like concentrations are less than 10 to the power, then the reactant is more than the product. Direction of the reaction, okay. Q is the reaction coefficient or the concentration coefficient, ठीक আছে. सेम टाइप से लिखबो যেমন ওটা লিখেছিলাম. if is equal to, if it's equal to the equilibrium constant, then it is at equilibrium. If Q is greater, তার মানে কি, concentration of the products are greater than the concentrations of the products, the concentration of if this is greater than K equilibrium, কিউ ইজ গ্রেটার দেন কে ইকুইলিব্রিয়াম, তাহলে আমরা বলবো যে উপরে নিউমারেটরটা বড়, তাহলে আমাদের কনসেন্ট্রেশন অফ প্রোডাক্টস আর মোর দ্যান দ্যাট অফ দ্য রিয়াক্ট্যান্ট, সো এটা ব্যাকওয়ার্ড যেতে থাকে। এটা যদি হয়, যদি কে কিউ ইজ ছোটো, দেন দিস ইজ মোর, সো ইট গোজ ইন দ্য ফরওয়ার্ড ডাইরেকশন। Le-Chatelier's principle. A change in any factor that determine the equilibrium conditions of the system will cause the system to change in such a manner to reduce the counteract of the effect. The effect on concentration change. Q is equals to C, D, A and B. Effect of concentration. Take for the granted this is being increased, so this increases. If this increases, it goes in backward direction. If D is decreased, so Q decreases. If Q decreases, it means the reaction this, it goes in forward direction. If A increases, তো বোঝা যাচ্ছে এখানে এটাও forward direction এ যাবে. Factors affecting effect of volume change. There are a few pages only. Effect of volume change. If the Ng is greater, the Ng is atho and Ng is 0. Okay. If the Ng is atho, it is inversely proportional. We can see if the volume increases, the Q decreases, and if the Q decreases, it means that the products decreases, so it goes in forward direction, and vice versa. And if it is lesser than this, it's directly proportional, and if it is not, it has no effect. The effect of pressure change. If Ng is greater than, again, volume, just the opposite, you can just study it and know the effect of temperature and the endothermic reaction. We have just studied that effect of addition at constant volume, effect of temperature, effect of addition of inert gas at a constant volume. We have no, at constant pressure equilibrium will shift in the direction of the greater number of moles or volume. The PC কি চিপস জানি না, আমি দেখে বলবো. Equilibrium shift in the direction of the greater number of moles or at constant pressure, the equilibrium shift in the direction of the greater number of moles or volume. No effect. Vapor density and degree of dissociation. If take it as, okay, the moles are given here, A minus X. The degree of dissociation is number of moles dissociated by total number of moles. What is the total number of moles dissociated? We can see it is A minus X minus total number of moles, which is initial moles এখানে নেবে total number of moles which is dissociated. divided by that of the reactant minus 1, and this is the after dissociation, this is before dissociation, before, after, number of moles of product by reactant. Bas, that's what we draw the line. Thank you.